Hello everyone. So I am putting this video as a part of a project for one of my graduate courses this semester. It's mainly for educational purposes, so hopefully you will find it useful. Now, we all are familiar with different programming languages like Python or C++, but chances are not everyone here has worked with Julia. Julia is also a very powerful programming language. It's known for its clean syntax and program performance efficiency. So today, I will be using Jupyter Notebook to walk you through some of the commonly used syntax in Julia. Now, just for a quick note, if you are looking for how to actually set up a Julia environment or create a notebook, there are tons of tutorials on YouTube. So I won't go over that part. Also, I am not going to spend some time on the basics like printing hello world. Instead, let's jump right into some of the more interesting stuffs, like the tools Julia gives us for manipulating images. Think of it like kind of what the photo editing software does behind the scenes when you apply different filters or effect to your pictures. And one more thing, this video is a part of a larger tutorial series of my teammates, and I am specifically covering a particular part. So each of us is covering a different topic. So if you want to check out those, I have left links in the description. Definitely take a look if you're curious about more of the tools. All right, then let's dive in and get started. So I will walk you through the basics. As I said, we'll start from downloading, loading, and images, then move on to pixel access, RGB values, and finally, some interesting manipulation such as invert or noisify or the grayscale effect for an image. In Julia, we can easily download an image from the internet using the download package. Here you can see an example code. We store image URL in a variable which is named image file name and download it using this syntax. Once the image is downloaded, the next step is to load it into Julia. We use the image packages for that. The load function reads the image file and stores it as an array, uh, which basically works like any other dataset. And this is the entry point of image analysis. Uh, Here we can see the image we have loaded. So basically, every image is essentially a grid of thousands of pixels, and they have coordinate as well. On top of that, uh, we can start our coordinate from the top left corner, and it propagates to other ones. In Julia, we can check the size of the image array, access an individual pixel by its coordinate, or even select a rectangular portion of the image. For example, to access the pixel with coordinate 50, 100, we can use this syntax. We can access any portion of the image as an array as well using the following syntax. The result will be like this. We are focusing on the head of the image. Not only that, each pixel contains three color channels, as we know, RGB, red, green, and blue. Julia lets us access these values easily using a dot operator. For example, pixel.r gives us the red value of the specified pixel. By combining these three, we can fully describe the color at any location of the image. Moving forward, another essential tool to manipulate image is function definition. In Julia, we can write functions serving some particular arguments. So this is an example of function structure. Now that we are familiar with all the tools, we can move on to the image manipulation part. In today's lecture, I will cover three types of effect that we usually use on our images. Firstly, the invert or the negative of an image. So basically, it's done by defining a function that inverts the color. So the main mathematical operation it does is as similar as given in the slide. Here we can see the results as the inverted image of the originals. We can also noisify our image to a random intensity with a range 0 to 1. For this, we have also we need also to define a function such that the function adds a randomness of intensity. And this is the result we get from noisifying our image. And lastly, and most commonly, we can grayscale our image by defining a function that converts our RGB values into a weighted coefficients and results the images like this. So I will discuss more details in the coding part. Hope you all have understood the objective of today's lecture. Now I will move on to the Jupyter Notebook to reflect our understanding in Julia. So now I have opened the Jupyter Notebook to make you understand the codes side by side or in parallel with the slides I have just shown you. Uh, to begin with, the first code we need to write, we need to define the address of the image we want to analyze or manipulate. For that, I'm writing the code. So basically, you need to have some address of your image here. For that, I have selected a particular image. I'm going to go to that and like copy the address of the image and get back to our Jupyter and just paste it here. And now we can just run our code. So we can see in the second line, it gives us some destination of the location where the image is downloaded. So now we need to load the image. To load the image, I might give some name to the image, like this is a dog, so I'm gonna call it Marley. So now you can see the image is loaded and we have it on our Julia notebook. Now we can access to its pixels and analyze the image with further effects. So after loading the image, we can access to its dimension or the pixels it has, the number of pixels it has by using the command called size. And the name of the image, it says it has pixel of 1080 by 1080. After that, we can access any of the pixel, like we name it pixel. And here we can see, we can randomly open a pixel that is like greenish. It might be located somewhere like here. We can also use their code for specifying a rectangular portion of the image. For that, we have to write down this syntax. So you can see I have focused on the head portion. You can just play with the coordinates, like you can put here 250, here you can put 300. and you can see the changes. The portion of the image has just shifted a bit. So we have already accessed the pixel, and now we want to access the RGB values. Each of the pixel has its own RGB values, like the pixel we defined above. To access RGB values, we can just basically put red value. So here dot R operator basically gives us access to the RGB value of that pixel. And here you can see some letters or numbers. You can just avoid N0F8. It's a tag type of the number. The value will be 0.361. And if we want the RGB as a whole, we can just write so here you will get the RGB values like 0.361, 0.69, and 0.486. You can go on and change the pixel coordinates, like I'm putting 500 here and like putting 250 here and load it again. And you can and you come here and load it again, and you can see the values of the RGB portions have changed as well. So moving on to the other part, we are gonna define some functions so that we can just apply different effect on the image. For that, here is on the left, we have the example format of defining a function. First, we want to create a function that inverts the image. And basically the mathematical operation it does is when we input a pixel RGB values, it outputs the values that are subtracted from 1. Why 1? Because all the pixel values are scaled to in between 0 to 1. Like R value is scaled to 0 to 1. Similarly, the G value or green value is also scaled to in between 0 to 1. So I'm going to define a function. Naming it invert. Uh, for the variables, I am gonna input some pixel, or I say color. It's like some abstract it takes some abstract RGB value. So I'm just defining it with the double colon. And in between, we have to put some arguments. What it will do, it will just simply uh, modify the RGB value. So I'm putting new red equals to uh, subtracting from the 1 and new. Okay, now we have to return something from the function. It will return us RGB values as so when we run the function, okay, there is some typo. Hope that's all right. So now we have defined a function, invert image, that basically inputs some pixel with some RGB values, and it converts its RGB values to its negative or like its complement, and we can have some result like if we define color black maybe. It should be RGB. Okay. So we have the black color here. Okay, it's not visible maybe, but if we use the invert image, or like use the invert image function to invert it and put color black into it, we'll get the invert of the black color. Similarly, we can try color red maybe. And now we have the red color. If we want to invert the same, we can just call it in the invert function, and as a result, we get inverted pixels. Okay, so moving forward, now we want to apply it in our image. So we have to just do the same and use the invert function, and inside we have to say the image we want to invert, but there is a catch. These are the only a pixel. These are not an array. These are a specific coordinate. But for Merle, it's an array or the matrix which has thousands of pixels. So basically, we are now operating with an array or matrix. So we have to put a dot in between so that it can like work with each of the element in the images. You can know like Google or do ChatGPT to have some more details. So here we can see the invert image we wanted. So I'll be moving forward to our next function definition. After inverting the image, we can just noisify an image by defining another function called noisify. A function noisify is defined such as it takes two input like intensity S and RGB values, often color. So after that, what does it do? It adds random value in between S to plus S, the intensity, to the RGB values. For that, you should be like familiar with some built-in functions like rand. Uh, for like three, it gives us three. Sorry, there is a typo. It gives us three random values. Also, like if you want to clamp a value in between a range, then you can use like x, you can say like x equals to 4.5, and you just clamp x in between 0 to 2 maybe, and yeah, the value is like clamped between 0 to 2. So if you have greater value than x, it will just clamp in between. So now I'm gonna define the function noisify. It will also take two variables. I should like define it differently, like this maybe color two, and this also abstract. I should like I guess I should use abstract RGB, and it also takes as input the intensity S, and yeah, it does. I am just keeping it in short. Inner equals to newer. And what does it do? It takes the color and RGB values and adds some random values to it in between plus S to minus S. For that, there is a like operation or like fixed mathematical equation like this. Okay, I should be fine with that, and doing the same for the other pixel values. It should be G, it should be B, and G, and here is the B. So what I'm doing is accessing the pixel values, pixel RGB values, and adding some random values in between plus S to minus S, as it's described on the left. Now, as return, we will get another RGB values, and it should be clamped in between 0 to 1, as our RGB is valid only in between 0 to 1. So now it's the end of the function. Hope I was able to define the function properly. I can check for the result. We can just call the function, and in between we can call the image we want to apply noisify, and as a result, it's a matrix, so I'm putting a dot, and let's check for the result. Okay. Oh, I haven't defined the intensity. So for intensity, I guess I can use 0.3. Also, what does it says in? Oh, that is also a typo here. Should run the function and say, okay. Mm, there any problem? It's giving me black. Oh shit. Why is there? Why that is 2? It should be like just S. Okay, sorry about that. Okay. Let's run this function again, and let's do Mali again. Yeah, we got a noisified image of Marley. So we are able to define another function that can manipulate our image. And for the last function, we are going to define a function that grayscales our images. Here we'll see function definition as like grayscale. Uh, we'll just choose a color or the pixel as input here. G maybe. It's abstract RGB. So after that, we are going to do some changes, like we are defining new RGB. Okay, so it will be applied to all of the red value, green value, and blue values. It's a weighted coefficient which is fixed for the grayscale. It's just an equation we are seeing in the left-hand side. So now we are going to return some outputs, and it will be RGB value as well, and it will be like just this one for each all the values. For the red values, it's also the same. The green values, it's also the same. And I'm just gonna end the function. Hope my syntax is all right this time. Let's run it here. Function is defined. Now let's test the function. So just grayscale and dot Murray. Okay. Okay, there is a typo again. Sorry about these. Okay. Oh, so here we have the like grayscale version of our image. You can do the same with any image you want. You have to just load it in your Jupyter notebook, and you can try out these fun effects for your any image you want to play with. So that's all for today's lecture. Thank you all for giving me your time.